Here we have a bunch of logarithmic functions whose derivatives we want to find, and we'll recall that if you have a function log y equals log base a of x, then the derivative is going to be y equals 1 over the natural log of a times 1 over x. So this can be extended if x is anything but x, if what's in place of x is a function, y equals log base a of u, then the derivative is going to be u prime times 1 over the natural log of a times 1 over u. So we'll need this simpler. Now you can use this more complicated version of it, except if it's x in here, then the derivative of x is 1, and so that doesn't affect your final answer anyway. So you can kind of imagine u prime equaling 1 right here. So either of these two forms work. If you just want to remember one thing, this is the easier one to do, although it looks more complicated. Letter A, so we just have an x over here, so we'll go ahead and use this form of it. Y prime would equal 1 over the natural log of 4 times 1 over x. You can simply write 1 over x natural log of 4, but whichever way you'd like to write it is fine. B, y equals ln x. Okay, well, we recall that natural log is simply log with a base of e of x. And so, in this case, y prime would be 1 over the natural log of e times 1 over x. Well, the natural log of e is equal to 1, so this is 1 over 1, or just 1, and so we get 1 over x. In letter C, we have 2.4 log base 8 of x. The coefficient doesn't really affect anything except that it stays there, so we have 2.4 times 1 over the natural log of 8 times 1 over x, and we're done. Letter D is a little bit more involved. We have to use this version of the derivative here because now, in this case, our u is 4x squared, and so we have to pre-multiply by the derivative of 4x squared, which is 8x, times, we have a coefficient here, so I'll lay that one down, times 1 over the natural log of 100 times 1 over x. So very similar in nature to the exponential function. We have to multiply by the u prime, then the coefficient, then this 1 over the natural log of the base times 1 over x, and that's the whole derivative. If you'd like to simplify this a little bit more, you can. 8x times 0.1 is going to be 0.8x. Now the cool thing here is that this is, this should be 1 over x squared. And the cool thing here is that you can actually cancel out one of the x's because we have the natural log of 100 times x squared. And so you can cancel one out here, and you get 0.8 over natural log of 100 times x. And that's probably most simplest form you can write it without having to do too much approximation.